जी स्टार्ट कीजिए.
Dear student, today we are going to discuss the Laplace transform. तो सबसे पहले हम जानते हैं कि Laplace transform होता क्या है और Laplace transform कैसे फंक्शन की निकालते हैं लोग. Laplace transform के लिए सबसे पहले आपको जरूरी है कि function should be of piecewise continuous and second criteria is that the function should be of exponential order. अगर कोई फंक्शन piecewise continuous है और exponential order का है, then the Laplace will exist definitely. But if any function is not a piecewise continuous or not satisfying the exponential order, then the Laplace may be exist or may not be exist. Means it is not a necessary condition, but it is a sufficient condition. When the exponential or function is of exponential order or the piecewise continuous, then the Laplace of the function will exist definitely. So let us check what is the meaning of the piecewise continuous function. The piecewise continuous function is, suppose that this function is defined between the interval a and b. In the if we define the domain in the subinterval of this, and the function is like this. So this is called the piecewise continuous function because we can see that the function is continuous in the subinterval, but it has a finite left and right hand limit. So if a function is continuous in the interval ab, and if it has the finite left and right hand limit in the every subinterval of the domain a1 b1, then we say that the function is piecewise continuous. For example, if I talk about sin x, so sin x is a piecewise continuous because if we divide it into the any subinterval, so its left hand limit and right hand limit will be finite, and it is also continuous in the subinterval. So it is a piecewise continuous. But if I talk about the tan x, and we know the tan x is like this and this. So tan x is what? It is not piecewise continuous because its right hand limit is minus infinity, left hand limit is somewhere else. So it is not finite. That is why this function is not a piecewise continuous. So if a function is a piecewise continuous and of exponential order, then the Laplace will exist. So now we are going to discuss the definition of the Laplace transform. So Laplace transform of ft is defined as the integral over 0 to infinity e to the power minus st ft dt, where the s is a parameter greater than a, where a is the function of exponential order a, and this s may be real or complex. Now let us find the Laplace of the function ft is 1. Let's take ft is equal to 1, and now we are going to find the Laplace of the function 1. So by the definition we can write 0 to infinity e to the power minus st, and ft is 1 dt. Ft is 1 dt. So this is what e to the power minus st upon minus s, limit 0 to infinity. So this is minus 1 by s, and when we put the limit, we will get e to the power minus 0. So this is minus 1 by s, this is 0 minus 1, so that is 1 by s. So the Laplace of 1 is 1 by s. Similarly, we can find the Laplace of the other function like Laplace of sin at, and this is what? A upon s square plus a square, and this can also be found with the help of the basic definition of the Laplace. So thank you very much for watching the video.